Hi guys, the point of this video is to basically demonstrate how much power one of these little MOSFETs can dissipate. Now this is a high power MOSFET from Fairchild Semiconductor. It's rated at up to 500 volts, 100 amps. But anyway, at the moment what I'm going to do is I'm not going to use it for its current capacity or voltage or anything like. I'm going to use it for a total different purpose, and that's actually power dissipation. It's got an extremely high power dissipation. It's rated at 2.4 kilowatt power dissipation. So it can dissipate 2.4 kilowatts of heat, but that's only if you maintain the case temperature at 25 degrees Celsius. Now, that's basically impossible to do here in my lab. So basically what I'm going to do is just submerge one in water. Now water will maintain the case temperature at 100 degrees Celsius. Anyway, basically what I'm going to do is I'm going to be operating the MOSFET in its Miller Plateau region. So it's never fully on, it's never fully off, it's just somewhere in between. So it'll act as a resistor. And the gate will be driven from this little board here. Basically, it's a load bank board, it's the same board that I use in my linear load bank. But basically, what we have is a little op amp in there. It's just a precision current sense op amp. It's an LTC 2050 op amp. Very very low offset voltage, and that's measuring the shunt. That's measuring the voltage across the little shunt resistor you see in there. That's a 1 milliohm shunt. Now, basically, what it's doing, it's reading the current flowing through, or measuring the current flowing through that 1 milliohm resistor, and it's driving the gate of this MOSFET in here, and it's giving us our closed loop feedback control. So I'll be setting a reference voltage with my power supply, and that reference voltage will be will represent the current which we're going to be dissipating, or the power which we're dissipating through our MOSFET in there. Anyway, so the power will be supplied from these lithium polymer batteries here. Now, basically, this is just a high power lithium polymer battery bank, which I use for a total different purpose, but in this case I'm going to be using it as the supply of power to my MOSFET, just to demonstrate how much power these can dissipate. Now the power will be measured through this power meter here. Basically it'll give us our current and voltage and power readout. Now basically all the power that's going to be coming in from this battery is going to be passing in through here, and basically straight into my MOSFET. So the MOSFET is going to be acting as a load. It's just going to be basically discharging the battery. Anyway, let's have a look. At the moment my reference voltage is 0.5 volts. Now at the moment that means nothing, it's just an arbitrary value because it depends on the resistors and my configuration down here. But let's have a look how much power that's 0.5 volts is going to give us. 736 watts we have. Check that out, guys. Now that water is basically boiling straight off the MOSFET case there. The water is maintaining the case temperature at about 100 degrees Celsius, and we're dissipating 736 watts, or 720 watts now, through that MOSFET. So we have 36 amps going in, 700 watts, and all that's been dissipated as heat in the water, into the water. I'm just going to lower this threshold now. So now we're down to 320 watts. Now I'm going to keep pushing it till it blows. So I just want to see what sort of power we can push through this one little MOSFET here before we actually short its junction. Now, basically, what's going to happen is as soon as the MOSFET shorts out or it blows, its failure mode is short circuit. The MOSFETs fail in short circuit, so when it does fail, I've got a little fuse on the other side of this board, which is just a surface mount fuse. It's just going to blow an open circuit, and it's going to stop the current flow. Anyway, let's have a look. I'm going to set this to some high value. Let's go up to 700 millivolts there, which should give us, whoa, that's 1 kilowatt. Anyway, we know that it's tolerating 1 kilowatt of power dissipation. So this one little puppy here is dissipating 1 kilowatt of heat. Anyway, let's go even further up. Alright, basically I've reached a point now where my battery voltage is dropping, and the battery voltage dropping, and it's reducing the power to the FET. So I've pushed that up further to 1 kilowatt. I've pushed the reference up to give me 1 kilowatt, and basically I'm getting a lot of voltage drop in the leads, and the battery voltage drop, the impedance in the battery. So the battery is actually quite warm. So I'm just going to replace this battery. We'll put a better battery on, and we'll try that again. Alright, I've swapped the battery out. I've just replaced it. Now, let's try that again. No, same thing. It's battery impedance. Anyway, that's 1 kilowatt I'm getting through there. I'm just going to ramp that up even more just to see what happens. Yeah. Anyway, thanks for watching, guys.